We now look at Coulombs law. And this law relates the force of attraction or repulsion between two charges. So if I have one charge, which is say positive, and another, let's assume that's also positive, and the charge on this one is given by Q1, and the charge on this one is Q2, and they should both be in coulombs. We use Q, little q or upper Q as the symbol for charge. Then Coulomb found that the force of electric attraction or repulsion would depend on the charge Q1, and it would depend on the charge Q2. So the bigger the charges, the bigger is the force of attraction or repulsion. In this case, it would be a force of repulsion. And if the distance between the two is r, well, the bigger the distance, the smaller will be the force. So as they get close together, then the force becomes stronger. So it depends on 1 over r, and he found that it doesn't depend on r itself, but on r squared. So this becomes an inverse square law of force. So he found that the force depends on Q1, Q2 over r squared. And then we have a constant of proportionality, which is called the Coulomb's constant. And its value is 8.99. Well, there are more digits after it, but we can just stay with 3 digits, 10 to the power 9, and the units would be newtons meter square per coulomb square. And Q1 and Q2 are in coulombs, and R is in meters. Now this is a force, so it's a vector, and so to write it as a vector, we put a line here, but the charges are scalars and r squared is a scalar, so we need to have a direction which we give as a unit vector r. And if this is 1 and that's 2, this is written as a force 1, 2, and this is written as a force 2, 1. That's the force on 2 due to 1. That's the force on 1 due to 2. So this is the force on 1, that's the force on 2. Now, if we are writing the force on 2, so if you're writing 1, 2, then this is the distance r between them, and this is the direction pointing from 1 towards 2 is the unit vector r1, 2. So this is r1, 2. And this would be whatever is the unit vector pointing straight from 1 towards 2. So this would be the equation or Coulomb's law that gives us the force on 2 due to charge 1. Now the magnitude of the force is simply the first part. And you can write, if you want to find the magnitude of F12, that's simply K Coulomb constant Q1. Just take the magnitude of Q1, take the magnitude of Q2 over r squared. So it doesn't matter whether it's positive or negative, that's the magnitude of the force. Now, if this charge is positive and this is positive, the force is going to be to the right. But if this charge is positive, Q1 is positive, and Q2 is negative, and we want to find the force F12, that is the force on 2 due to 1, which is going to be a force this way or this way. We know that it's going to be attractive, so it's going to point this way. So based on this equation, we would still write it as K Q1, Q2. Now this will be a positive number, and Q2 will be a negative number over r squared, and the unit vector r1, 2 is still pointing from 1 to 2. So the direction is still pointing from 1 to 2, but because Q2 is a negative number, the whole thing will become negative, and the force will start pointing in the opposite direction. So you multiply r12 with the minus r12 becomes in this direction, whereas plus r12 is in this direction. So we keep the same equation, but the charge being negative will cause the force to be to the left. And if both are negative, well, you have two negatives, they again become positive, and the force again becomes to the right. Another thing to note is that the magnitude of F12, which is here and to the right, is exactly equal to the magnitude of F21. So the magnitude of this force is exactly equal and opposite to this one, and similarly the magnitude of this of a force F, the force on this one, which would be F21, which would be this way, would be exactly equal in magnitude to this other force, but in opposite direction. And that comes from Newton's third law. And also comes from here, because if you write F21, just flip over, make it 2 and 1, you still get the same value. Now let's do an example on this. So let's suppose we have two charges, and let's stay on the x-axis. So we have one charge, Q1, this is charge 1, and this is charge 2, and Q1 is 5 microcoulombs, Q2 is 3 microcoulombs, and the question is, what is F12 and what is F21? Now this charge is located at x equals 0.5 meters, and x2, which is this is the distance from here to here, is x1, and the distance from here to here is x2, and x2 is 2.0 meters. So now the force on 2 is going to be K Q1 Q2 over R12 square, and the unit vector from 1 to 2. Okay, now this is going to be 8.99 into 10 to the power 9 Newton meter square per coulomb square. That will be the K. The Q1 is going to be 5 into 10 to the power minus 6 coulomb. Q2 is going to be, they're both positive, so it's going to be 3 into 10 to the power minus 6 coulombs, and the 2 coulombs will cancel out, divided by R, and this is 2 and that's 1, so that's 1.5 meter square. And because we're going from 1 to 2, so R12 is simply the I vector, which comes out to 0.0599 newtons. We can see that the meter square will cancel with meter square, and the coulomb will cancel with the coulomb square, so we're left with the meter. So that will be the force here, and we have it's in the I direction. Well, better written as 0.0599 I newtons. And similarly, if we want to find F21, that will be the same equation, and we will have 8.99 into 10 to the power 9. We have 5 into 10 to the power minus 6, 3 into 10 to the power minus 6, and the R is also the same, 1.5 square. But now because it's F21, so the F21 is going to be, R21 is going to be to the left, so it's minus I, and so it's going to be minus 0.0599 I newtons. Okay, so that will be the force F12, and that's the force F21. Now if we do the same thing with the Q1, let's do a second example. If Q1 is taken as 5 microcoulomb and Q2 is taken as minus 3 microcoulomb, then the F12 is going to be K Q1 Q2 over R square R12. That's going to be 8.99 into 10 to the power 9, and 5 10 to the power minus 6 and minus 3 into 10 to the power minus 6 over 1.5 square, and the direction vector r12 is this way, so it's plus I, and we will get an answer of 0.0599 I newtons, and the direction is, and we have this minus sign here, so it's negative, which means that the force is going to be to the left. So if this were positive and this were negative, the force would be to the left.